So the next next section is working on perfect squares and perfect cubes. And this is just kind of an introduction for you, but I just want you to know that as you move along in math, like in high school, I'll give kids a quiz over the ones through at least 20. I think as a sixth grader, you should know the ones up to 10. So you should know the result of squaring a number is called a perfect square. So you should know the first 10 perfect squares, and I bet you already know a lot of them. Okay, for example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Therefore, 1, 4, and 9 are examples of perfect squares. Okay, and so perfect squares will be really important as you move into algebra because you're going to use them for different things. So why are they called perfect squares? When they're drawn geometrically, they make a perfect square. So for example, I drew something that has a side length of 1 and 1, and the square is 1. So if I come over here and draw 4, and I go up 4, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's called a perfect square. So if I were to do 5, and go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Sorry, you can hear my puppy dog, my old puppy dog. We love him, but he is old and he is napping. So you get 25. Oh, I woke him up because he knew I was talking about him because I said old. Now he's moving. Okay, so that's going to have, I should have counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, and you can keep going. You can do 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if I count these squares, it's going to be 36. These are all examples. 16, 25, 36 are all examples of perfect squares. Okay. In sixth grade, I'm not asking you to memorize all 20 of them, but I do think, like I said at the beginning, I do think as a sixth grader, you should have the first 10. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36. We just drew those. 7 times 7 is 49. You should know that one. 8 times 8 is 64. You should know that one. 9 times 9 is 81. You should know that one. And then 10 times 10 is 100. Okay, now, as you get older, I'm going to tell you, you might as well try to memorize these bottom ones, but you can use your notes as you're doing your homework. I would just, these, by the time you're in 10th grade, you're going to have these bottom ones memorized as well. I'm not asking you to memorize them now, just the green ones. So 11 times 11, this is 121. 12 times 12 is 144. And I'm just using the pink table for this. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256. 17 times 17 is, 289. I almost said 3. 18 times 18 is 324. 19 times 19 is 361. And 20 times 20 is 400. I do not think that you should have these blue ones memorized, but I do think you should be able to recognize them. Okay, you can use your pink sheet to find them because all of those numbers are on your pink sheet. Okay, a non-perfect square is a whole number that is not a perfect square. Okay. So if the number is a perfect square, we're going to write yes, and then write it as the whole number squared. So like 121, yes, that's a perfect square. That is 11 squared. 50 is not on my list because 7 times 7 is 49. 8 times 8 is 64. The other day when we were working, Tilly was doing some where she had to kind of estimate it. So 50 would be like 7.1 squared. It's going to be a little bit more than 7, but it's not a whole number, so this is a no. 324 is on my list, so I'm going to write yes, and I'm going to write 18 squared. All right, I would like you to do 4, 5, and 6. Okay, 4 is a yes, and it's 4 squared. 5 is a yes, and it's 9 squared, and 10 is a no. Okay. All right, I think you got that part. I'm not so worried about it. So we're going to jump to number 10. In the boxes, fill in with consecutive numbers that make the statement true. Okay, so this is kind of what Tilly and I were doing. 14 is between 3 squared, because that's 9, and 4 squared, because that's 16. So when we start to learn more about this as you get older, you're going to kind of learn how to estimate what it is. So it's kind of important that you can see the two numbers it's between. Okay, so 132. 132, if I follow these numbers, I'm just going to use yellow. 132, here's 121, and it jumps to 144, so that happens somewhere in between there. So my answer is between 11 squared and 12 squared. Okay, I would like you to pause and do 12 and 13. Pause and do 12 and 13. Okay, 12 is between 64, which is 8 squared, and 81. And 13, I've even got a cheat, 305, that's going to be, 305 is going to be between these two. So 17 and 18 squared. And so I am okay if you use your table on this. I just use the table. Okay, so on number 14, it wants you to highlight the ones that are perfect squares and divisible by 4. So I'm just going to start. 12 is not a perfect square. 36 is. Is it divisible by 4? Yes. The answer is 9, so I'm going to shade this one. 48 is not a perfect. 100 is a perfect square. Is it divisible by 4? Yes, because it's 25. 128 is not. 144. So remember, the rules with 4 is that the last two numbers, so I'm going to use black here and then I'll kind of erase it. So is 44 divisible by 4? No. Yes, 44 is divisible by 4. It's 11. So then that would mean 144 is also divisible by 4. 200 is not a perfect square. 256, remember I'm just looking at here, is 56 divided by 4? 1. Yes, it is. So that means that this one is also divisible by 4. Okay, and 264 is not on my list. Okay, so the next one is a perfect square and divisible by 6. So 6 is not, 24 is not, but 36 is a perfect square and it's divisible by 6. 81 is a perfect square. Remember, your rules for being divisible by 6 is it has, stop, nobody's coming to get us. It has to be divisible by 2 and 3. 81 is not divisible by 2 because it's not even. Okay, so I'm not going to shade 81. 196, let's see up at my table. Yeah, 196 is a perfect square. It's divisible by 2. Is it divisible by 3? Remember, we add the digits. 1 plus 9 plus 6. That's 16. Is 16 divisible by 3? Nope. So 196 isn't divisible by 3, which means it's not divisible by 6. 218 is not a perfect square. 270, no. 300, no. 324 is. It is divisible by 2 because it's even. And is it divisible by 3? 3 plus 2 plus 4 is 9. Yep, it's divisible by 3. So if it's divisible by 2 and 3, it's divisible by 6. All right, I would like you to try 16. Okay, non-perfect squares. 5 is a non-perfect square and it's odd, so I'm going to shade it. 25 is a perfect square. 64 is a perfect square. So I can't even look at those ones. 105 is a perfect square and it's odd. 141 is a perfect square and it's odd. Not a perfect square. Okay, 169 is a perfect square, so I'm not looking at it. 256 is a perfect square, so I'm not looking at it. 389, look, it's on my list. No, 389, that's a 2. 289 is highlighted. It is on my list. And 361, also 19 squared. So all of those are perfect squares at the end, so they're not even right. Okay, so if you didn't try 17, try it now. Okay, 17 is a non-perfect square divisible by 8. 8 is a non-perfect square. It's not a perfect square, and it's divisible. 16 is a perfect square. No. 64 perfect square. Can't look at it. Perfect square. All right, 136. I don't know if it's divisible by 8, though. So 1. Okay, it is. So it's not a perfect square, and it's divisible. 172 is not a perfect square. I'm going to see if it's divisible by 8. No, because there's going to be a remainder, 4/8. So that's a no. 256 is a perfect square, so I'm not even looking at it. 320, I'm going to see if 320 is divisible by 8. I believe it is. 40, yep. So I'm shading that guy. And 400 is a perfect square. Okay, so these are perfect squares. We're going to also look at perfect cubes. Okay, a perfect cube is the result, cubing a number is a perfect cube. The result of a perfect cube is one that comes out evenly if you multiply it 3 times. 1 cubed, 1 times 1 times 1 is 1. 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. 3 times 3 times 3, that's 9. 9 times 3 is 27. These are examples of perfect cubes. So 1, 8, 27 are perfect cubes. Why are they called perfect cubes? Because if you draw them, which I can't draw, if you drew them, then it would be the volume of that cube. So it would be how many cubes fit in there. Okay, so if it was a 2 by 2 by 2, you would have 8 cubes that would fit in there. Okay. Again, these are numbers. The first 10 are the numbers that I make my kids memorize. You may or may not be ready to memorize, but you should know 1. We just did 2 times 2 times 2, that's 8. 3 times 3 times 3 is 27. 4 times 4 times 4, that's 16. 16 times 4, you can use your pink chart, is 64. Okay, the next one is 5 times 5 times 5. So the answer is 125, just so you know. Okay, I'll just give you these ones because they're bigger. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. And 10 times 10 times 10 is 1,000. Okay, so I'm giving you those ones. You would need to recognize up to the first 10 perfect cubes. So 125 is a yes. It's a perfect cube. It's 5 cubed. Okay. 100 is a no. It's not a perfect cube. It's a perfect square, but it's not a perfect cube. 3. Oh, am I supposed to do perfect cube? I didn't read the directions. It says perfect square or perfect cube, both or neither. So I apologize. This is a yes. It's a perfect square, 10 squared. Okay. 324 is a yes. It's one of those. It is 18 squared. 343 is a yes. It is a 7 cubed. I would like you to try the bottom 4. So this one is tricky. This one is both. Okay, this is 8 squared, but it's also 4 cubed. And that comes into play as you get older. 60, I didn't write that down anywhere. That's neither, it's none. 256 is a yes. It is 16 squared. And 400 is a yes. It is 20 squared. So there's not very many numbers that are both, but there are a couple. Okay, and 64 is one of them.